To use the definition of a logarithm to solve logarithmic equations, we will first express the equation in the form log base b of m equals c, some constant. 2, we will use the definition of a logarithm to rewrite the equation in exponential form. Remember that log base b of m equals c means that b to the c equals m. 3rd, we'll solve for our variable. And then 4th, and this is important, 4th, we will check any proposed solutions in the original equation. Include in the solution set only values for which m, that would be this argument of our log, for which m is greater than 0. Let's solve for x. Always check to make sure the solutions that you get are in the domain of the function. All right, so the first one we have is log of x equals negative 3. Well, because our base is 10, because this is a common log, we can write this in exponential form as 10 to the minus 3 equals x. Well, that is our value of x. Let me rewrite this as 1 over 1,000. 10 to the negative 3 is 1,000th, so that is our value for x. Now, I know that if I plugged 1/1000th, I evaluated this function for that, that would be positive. It's a positive 1/1000th, so this is valid. For our next equation, we have log base 5 of quantity, x minus 4, and this equals 2. So writing this in logarithmic form, well, it's in logarithmic form. Now, because our value as an argument is x minus 4, that means that x must be greater than 4. Remember, recall back to our domain. So if our values are not greater than 4 as a solution, then it can't be possible. It's out of the domain. So we can write this in exponential form as 5 to the second power equals x minus 4. Well, the left-hand side of that equation would be 25. So 25 equals x minus 4. And if we add 4 to both sides, we find that x equals 29. Now, because x must be greater than 4, we know that x equals 29 is a valid solution. Next, we have 2 more equations. Solve for x. Always check to make sure the solutions you get are in the domain of the function. Do you think it's important yet? All right. Well, the first one we have is natural log of x equals 7. Well, we don't have a base written here, but natural log indicates we have log base e of x equals 7. So we can write that as e to the 7 equals x. And again, that tells us that x is equal to e to the 7. Now, looking here, our argument is just x, so that means that x must be greater than 0. Therefore, e to the 7 is perfectly valid. And so x equals e to the 7. Now, for our last example, we have log base 5 of, and our quantity here is 8 minus 7x, close parentheses, equals 3. It's in the logarithmic form. Now, 8 minus 7x is greater than 0 whenever, let's see, we'll subtract 8 from both sides, so negative 7x is greater than negative 8. And then dividing by negative 7, we see that x is less than 8/7. So we need to check that our answer is less than 8/7. Now let's write this in exponential form as 5 to the third power equals 8 minus 7x. Now 5 cubed is 125. So 125 equals 8 minus 7x. And we'll subtract 8 from both sides. All right, so that is 117. So 117 equals negative 7x. And then dividing by negative 7 on both sides, we see that x is equal to negative 117 over 7. Well, is that less than 8/7? It is, because it is negative. So x equals negative 117 over 7 is a valid solution.